Hello everyone, myself Vanita MH. I am working as a lecturer in Government Polytechnic, Carpet. I heartily welcome you all for this session. In this session, I am going to speak about ARM Controller Unit 2, that is ARM Instruction Set. The outcomes achieved in the last session. In the last session, that is session 1, I covered the topics like fundamentals of ARM instruction set, ARM data types, conditional execution. Now I will recall some points about this session. In fundamentals of ARM instruction set, we learned ARM will define two types of instructions. One will be the ARM state, that is it defines 32-bit instruction, and second will be the thumb state, it is 16-bit instruction. Then our ARM instructions are all 32-bit long. It means that there are 2 to the power of 32 possible instructions. Then our ARM instruction always uses loading and storing architecture. What do you mean by loading and storing architecture? Our ARM data operating instruction does not manipulate data within a memory. So, to manipulate the data within a memory, first we have to store the data into the memory and retrieve the data again into the register. Then we have to go for the manipulation. To do all this process, we have to go for this load and store architecture. Then we learned ARM data types. Data types are nothing but it will define what type of data you are going to use. Mainly, we will be having 4 data types that you know. One will be the byte, second will be the half word, third will be the word, and fourth will be the double word. In these 4 bytes, our ARM controller is using a word data type. Word data type means it's a 32-bit because our ARM processor is a 32-bit processor. So it is using a word data type. Then you learned about the conditional execution. I had already told you ARM controller executes only the conditional instructions. It means you are giving some condition to the ARM controller to execute. It will check that condition. If that condition is true, then only it will execute the instructions. Otherwise, it will leave that instruction and it will go for the next condition, and the process will continue as it is. It means ARM executes only the conditional instructions. Next, learning outcome for this session. In this session, I will continue this ARM instruction set. In this session, I'm going to speak about the operation of the barrel shifter, why you need this barrel shifter, how it will be operated, and different shifting operations performed with this barrel shifter. So, the learning outcome after this session, I assure you that you can easily write the operation of a barrel shifter, and also you can easily illustrate the different shifting operations performed with this barrel shifter. Now we will see what do you mean by a barrel shifter. My dear students, in microcontroller the 4th semester, you learned about the rotate left, rotate right operations, and you will be having a specific instructions for that in a microcontroller. I think you remember that one. RLC rotate left with carry, RRC rotate right with carry. You did all these things. It means microcontroller is having a specific shift instructions to perform rotate right or rotate left. But in our ARM, it don't have actual shift instructions. It means there is no instruction is there in ARM to specifically tell to do left right or to shift right or left. This is a main drawback in our ARM controller. So what designers thought, if we want to do some shifting operations, means how to do in ARM controller. For that, they introduced one mechanism, that is they introduced one device, and using that one they doing these shifting operations in our ARM processor. What is that mechanism? This is nothing but a barrel shifter. A barrel shifter is a device which is used to shift a 32-bit data in ARM left or right with a specific amount that you are giving. It means it is the barrel shifter will shift the content. How many times to shift, whether right or left, it is doing that mechanism. So why we need this barrel shifter means this barrel shifter will speed up our ARM processor, and also the flexibility of the ARM processor will be increased by using this barrel shifter. So ARM has got barrel shifter in its data path, which can maximize hardware available on chip usage. So this is a diagram which shows the data flow between ALU and barrel shifter. This is the ALU, arithmetic logic unit. In this, all arithmetic and logical operations will be performed. To do arithmetic and logic operations, we have to give data, right? So two data you have to give. The one data will be from the register Rn and another data will be from the register Rm. Here, one of the data, that is Rn, is given directly into the ALU. It means the content of the register Rn is not processed. It means it is not processed anywhere. Directly the content of register Rn is given for an ALU, and then the content of register Rm. It means one of the data, not both, one of the data is given prior to the ALU. Prior to the ALU means before giving to the ALU, you are applying that RM into the barrel shifter, where you are specifically telling to do whether shift left or right. You are performing that operation. Then you will be getting some result. That is nothing but result N. Whatever result you get after the barrel shifter, the result N, that is given for an ALU to perform the operation. By doing this process, you can increase the flexibility of our ARM controller. Then in arithmetic and logic unit, it will take the no pre-processing data, that is Rn, and pre-processed data, that is N. Both will be taken in an ALU, and it will perform the operation whatever you are giving, and the result what it gets, it will be stored in a destination register RD. This is the picture of barrel shifter, how it works. Then the data processing instructions are processed within the arithmetic and logic unit. I told you in this diagram, all data processing unit instructions are all working in this ALU only. Then a unique and powerful feature of the ARM processor is the ability to shift the 32-bit binary pattern in one of the source registers left or right by a specific number of positions before it enters the ALU. This shifting operation increases the power as well as the flexibility of many data processing operations. Now we will see the different shift operations performed within the barrel shifter. There are mainly 5 different shift operations that are performed within a barrel shifter. They are LSL, logical shift left; LSR, logical shift right; ASR, arithmetic shift right; ROR, rotate right; RRX, rotate right extended. These are the shift operations that you are going to use within a barrel shifter. Now we will see each one separately with a neat example. First, we will see what do you mean by this LSL. LSL is nothing but a logical shift left. This LSL is used to shift the content logically left 0 to 31 places. See here, in this destination you will be having a data. The data will be shifted left like this. It is shifted like this. It means the bit 0 will be vacated and bit 31 will be moved to the carry flag. In logical operations, the vacated places are all filled with 0. It means it can be a right shift or it can be a left shift. If you get a logical word, then the vacated places are all filled with 0. So the bit 0 is filled with 0 and bit 31 is moved to the carry flag. The LSL is also having some special character. What is that? This LSL is nothing but it is doing a multiplication operation by powers of 2. It means multiplication operation means whatever the content that you are going to shift, that content that register content is divided by, it is multiplied, sorry, it is multiplied by 2 to the power of whatever amount you specified. It means, you consider this example, R3 comma LSL immediate 5. It means you are shifting the content of register R3 logically left by 5 times. You are shifting the content of register R3 left by 5 times. It means it is equivalent to multiplying the content of register by 2 to the power of amount. Amount is nothing but 5. So R3 into 2 to the power of 5, that is 32, will give the same answer. You can do it by rotate, you can do it this operation by shifting left by 5 times, or you can directly multiply the content of register R3 by 2 to the power 5, that is 32. Consider this example. In this example, I took R5 is equal to 0.2 and R7 is equal to 0.3. Okay, dear students, I request you all to take one book and pen and do it with me only, because this is the instructions. If you see this one, you won't get it. I will tell you the procedure and all. You please carry over there, and finally we will tally the answers. Okay. So here R5 is equal to 0.2 and R7 is equal to 0.3. The instruction will be move R7 comma R5 comma LSL immediate 2. It means the content of register R5 is it is shifted logically left 2 times. Okay, so we will take the content of register R5, that is 0.2. 0.2 means 00000010. We have to shift this content 2 times. If we shift logically left 1 time, means what you will get, 00000100. Then you have to shift it again. It means 00001000. So the answer is 8. So this is the answer. You can do it like this also, or I told you LSL means it is nothing but a multiplication by 2 to the power of amount specified. So the content is 2. 2 into 2 to the power of amount specified is 2. So 2 into 2 to the power of 2 is nothing but 2 into 4, that is nothing but 8. So the answer is 8, the same. So your answer is correct. Okay, next will be the LSR, logical shift right. What do you mean by logical shift right? The logical shift right is nothing but shifting to the right 0 to 31 places. So logical, I already told, logical means the vacated place. Here the vacated place is nothing but bit 31, that is filled with 0, and the bit 0 is moved to the carry flag. Okay, like LSR is doing the operation like dividing the content of register by 2 to the power of amount specified. You consider here R3 comma LSR immediate 5. What do you mean by this? You have to rotate right the content of register R3 by 5 times. So it is same as you have to divide the content of register R3 by 2 to the power of 5. That is R3 divided by 32 is same as shifting the content of register R3 by 5 times to the right. Now we will see that one. You consider this example. The R5 is equal to 0.8 and R7 is equal to 0.3. Now consider this instruction. Move R7 comma R5 comma LSR immediate 2. What it will do? You have to rotate, you have to shift, logically shift right the content of register R5 by 2. So consider, take this value 0.8 means 00001000. The first time you have to shift it, the answer will be 00000100. Next time you have to shift again 00000010. So the answer is 2. You got the answer. This can be done in another way also. That is 8 divided by 2 to the power of 2. I told you it's a division method. 8 divided by 2 to the power of 2 means 8 divided by 4, that is 2. So the answer is same. You got it? So the next will be the ASR, that is arithmetic shift right operation. The arithmetic shift right operation is same as logical shift operation, but you have to keep in mind that when you get a logical word, then the vacated places are all filled by zeros. If you get the word as arithmetic, then you have to fill the vacated places by the sign bit. Whatever sign bit you have, that is in this case The 31st bit is the sign bit. If the given value is positive, means that sign bit will be 0. If the given value is negative, then that sign bit will be 1. So you have to see that one. If the sign bit is 0, the shifting operation will continue with vacated places filled by zeros only. If the sign bit is 1, the shifting operation will be carried out with the vacated places filled by 1. You take care of that one. That is indicated by this diagram. That is indicated by this diagram. You have to shift this by right. Okay. The bit 0 is moved to the carry, and bit 31. Bit 31 is moved to the next bit, that is bit 30th. Then bit 31 is nothing but the sign bit. Whatever sign bit you had earlier, that is moved continuously like this. Consider this example, R3 comma ASR immediate 5. Divide the content. This is nothing but you have to rotate, arithmetically shift right R3 content by 5 times. Okay, first we will take one example. The R5 is equal to 08 and R7 is equal to 03. The instruction is move R7 comma R5 comma ASR immediate 2. That is, the content of register R5 is arithmetically shifted right by 2 times. We will take this content. 08 means 0000 1000. Before moving on to the operation, first you see the sign bit. Here the sign bit is 0, so the number is positive. The vacated places are all filled by zeros. Okay. For the first time when you go on shifting, the answer will be 0000 0100. The next time 0000 0010. So the answer will be the 2. Okay. In the next example, you consider this one. R5 is equal to 80. 80 means 1000 The sign bit is 1. What do you mean by that? The sign bit is 1 means the given number is negative. Given number is negative means you have to shift it right by moving the sign bit to the right. It means the sign bit is 1 means the vacated places are all filled by 1 only. Okay. So the first time 80 means 1000 for the first shift, the answer will be 1100 For the next time it will be 1110 So the answer will be E0. You check that one. The next rotate operation will be the ROR, that is rotate right. The rotate right is nothing but it shifts bits to the right and wrap around as they leave the LSB and appear as an MSB. It means here it is shifted to the right, the LSB will appear as an MSB and MSB will be shifted to the next one. It is rotating like this. Example R3 ROR immediate 5 means the content of register R3 will be rotated right 5 times. 5 times you have to rotate it. The bit 0 will be appearing as a bit 31. It means LSB is appearing as an MSB. So consider this example. The R5 is equal to 02, R7 is equal to 03. Move R7, R5, ROR immediate 2. It means the content of register R5 is rotated right 2 times. So 02 means 0000 You have to rotate it 2 times. For the next time, the answer will be 0000 The next time, the 1 will be, LSB will be appearing as an MSB. So the answer will be 1000 So the answer is 80. See here, the answer is 80. So the last one will be the RRX, that is rotate right extended. Here X stands for rotated right, X stands for extended. It means it is same as ROR, but that X indicates you have to rotate it by taking a carry flag. See here, you have to rotate the bit, you have to rotate right. The bit 0 will be appearing to the carry flag. Whatever carry flag you have, that will be shifted back to the bit 31. That is rotate right extended. The bit 0 is shifted to the carry. Example R3, RRX immediate 5 means it will rotate right with carry 5 times. It will take the carry and it will rotate with carry 5 times. You take this example. In this example, R5 is equal to 02 and R7 is equal to 03, and I took carry as a 1. Previously, I set carry as a 1. R5 means 00000010. For the first time, it will be shifting. Shifting means the carry will be becoming an MSB and it is rotating right. Then the answer will be 0. Carry will be shifted means 10000001, right? For the next shift, the carry is now the carry is 0, it is shifted means the MSB will be 0 0100 0000 and the carry will be 1. So the answer is 40. Okay. Okay, dear students, in this session I covered some topics. Now I will tell you whatever questions they can ask from this session in a exam. In an exam, what are the possibilities of asking questions in this session, I will tell you now. First question, list the different shift operations performed within the barrel shifter. Here you see the marks for how many marks they given. If they ask for 5 marks means you just write the shifting operations, that is LSL, LSR, ASR, ROR and RRX. That is enough. But if they ask the same question for 10 marks means just you write one sentence and one example for each. Okay. The second question will be the explain barrel shifter with a neat sketch. Neat sketch means you have to write that diagram. I told you know the data flow between barrel shifter and ALU. You have to write the diagram. Then you have to define why you need this barrel shifter and also you have to write the working principle of this barrel shifter. Next, explain 5 different shift operations that can be used with barrel shifter. This question was asked in April-May 2018. It is for 5 marks. 5 marks means you first you list out and you explain each one by one sentence each. If time permits, you give one example, it is enough. So, I think dear students, from barrel shifter, they always ask one question whether they ask operation of a barrel shifter or they ask for diagram of a barrel shifter, block diagram of a barrel shifter. So you read this one thoroughly. Don't leave this. You read barrel shifter and its shifting operations thoroughly. Okay. Okay. Now we will see some multiple choice questions that can be asked from this session. The first question will be arm as dash which provides a mechanism to carry out shifts. I already told you in the starting only microcontroller is having a shifting operations but our ARM don't have shift instructions. To do that one, ARM is having a special device called a barrel shifter that is mainly used to do or carry out shifts. So the answer is barrel shifter. The second question, in ARM, barrel shifter provides dash different shift operations. I already discussed with you, a barrel shifter provides 5 different shift operations. So the answer is 5. Next one, the LSL stands for. LSL means it's a logical shift left. So the answer is A, that is LSL. Next one, LSR stands for. LSR means logical shift right. LSL means left, LSR means right. So it is logical shift right. The answer is B. ASR stands for. ASR means arithmetic shift right. Arithmetic shift right. So the answer is C. Arithmetic shift right. So next one, RRX stands for. Dear students, don't confuse with the ROR and RRX. ROR means it's a simple right and RRX means it is also a right operation but with respect to carry. You have to consider the carry, it's an extended one. So RRX stands for rotate right extended. So the answer is D. The next question, ROR stands for. ROR is nothing but rotate right. So answer is D, rotate right. Then LSL provides the value of a register multiplied by a power of dash. Okay, now you consider one point. LSL is mainly used to multiply the content of a register by 2 to the power of amount specified. It means LSL is mainly for multiplication and LSR is mainly for division operation. Division means it will divide the content of a register by 2 to the power of amount that you are going to specify. So LSL provides the value of a register multiplied by a power of 2. The answer is 2. LSR provides the value of a register dash by a power of 2. It means LSR means it is divided by a power of 2. Then the last question, ALU stands for. ALU means it always performs both arithmetic and the logical operations. It is a unit. It is performing both. So the answer is a arithmetic and logical unit. U means unit. So the answer is C. Okay. To prepare this session, my dear students, I referred prescribed textbooks that is given in our syllabus. That is ARM System Developer Guide, that is Andrew Laws, and ARM Assembly Language, that is William Hall. My dear students, please refer this first one, Andrew Laws, because they given a lot of examples, the solved examples with explanation, so that you can easily understand that one easily, and you can go through that examples, so that the instructions, each instructions you can study very easily without any problem. Okay, you read this one, and this will increase your knowledge. Don't stick on to notes and PPTs. That's all. You yourself independently start to read all these textbooks. Okay. Finally, I would like to thank the Shant Kumar sir and the Rangashamaya sir for giving me an opportunity to prepare this video and also to present in front of you. I thank our DTE for selecting me as a content developer for this ARM controller. I would like to thank all my dear students for your support, and I thank everyone. Please go through this video and learn something. What I told, you learn that one, then I will be happiest. So all the best, dear students, and thank you.